2.6, solving quadratic equations by completing the square. Today's objectives, we are going to solve quadratic equations using square roots, and then we are going to solve quadratic equations by completing the square. Solving a quadratic equation using square roots, when we have a quadratic in the form of ax squared plus c equals 0, and there is no middle or b or linear term, bx, we can use square roots to solve the quadratic. We first want to isolate the x squared term, and then the inverse of squaring something is square rooting it, but we just need to remember that we need to put the plus or the minus in front of the square root sign. Looking at example 1, it says solve using square roots. So step number 1 is to isolate our squared term. So the inverse of negative 16 is plus 16. The inverse of squaring something is square rooting it. And when we take the square root of 16, we get x is equal to positive or negative 4. When we look at example B, to isolate our squared term, we first need to add 27 to both sides of our equation because it's the inverse of a negative. The inverse of multiplying by 3 is dividing by 3. So we have x squared is equal to 9. The inverse of squaring something is square rooting it. So we get x is equal to plus or minus 3. The inverse on example C is adding 5. 7 plus 5 is 12. The inverse of squaring is square rooting. So we have x equals plus or minus square root of 12. We need to simplify using our prime factors. So we simplify radical 12 as plus or minus 2 roots of 3. When we look at example D, our squared term is already isolated, so we're going to take the square root of both sides. So we're left with x plus 8 on the left, plus or minus 6 on the right. We then have x plus 8 equals positive 6. X plus 8 equals negative 6. The inverse of adding 8 is subtracting, so one of our solutions could be negative 2. And our other solution could be negative 14. So now that we've finished solving by using square roots, we can now move into solving by completing the square. So the first thing we need to make sure of is that the coefficient of our a, or our coefficient of our x squared term, is 1. We need to move the constant term to the opposite side of our equation and add our boxes. We need to divide the middle term by 2, square it, and put that in both of our boxes on both sides. We need to simplify. We need to factor our perfect square trinomial, and then finish by solving for x. So on example 1, what does that look like? Our a is already 1, so we're good there. We need to move our 7 to the other side of our equation by adding it. So we have x squared plus 6x plus box equals 7 plus box. Remember, whatever we add to one side of our equation, we must add to the other. We're creating a perfect square trinomial, so underneath we are going to have some quantity, x plus or minus something squared. So in our boxes is going to be our b divided by 2 squared, and in our perfect square down here is going to be our b divided by 2. So 6 divided by 2 gives us a positive 3. When we square that positive 3, 3 squared is equal to 9. So we place 9 in both of those boxes, combined our like terms. So we get 16 on the right-hand side And now we can finish by solving using square roots. So our squared term is isolated, so we can take the square root of both sides. Do not forget your plus or your minus. So it'll be plus or minus 4. So we have x plus 3 equals positive 4, x plus 3 equals negative 4. The inverse of adding is subtracting, so x can equal 1 or x can equal negative 7. When we look at example B, we notice that our a is 1, so we are going to move our constant to the right-hand side using the inverse operation. Set up our perfect square. We are going to do b divided by 2. So negative 10 divided by 2 gives us a negative 5. In our binomial, b divided by 2 squared is going to go in our boxes. Negative 5 squared gives us a positive 25. Combined our like terms, negative 7 plus 25 is plus or minus square root of, not square root, plus or minus 18. When we take the square root of both sides to solve by using square roots, it will be x minus 5 equals plus or minus square root of 18. We then can simplify the square root of 18 to 3 roots of 2. So we have plus or minus 3 root 2. Add your 5. 5 and 3 roots of 2 are not like terms, so we leave it 5 plus or minus 3 root 2. On example C, you notice that there is a 32 already on the right-hand side, which is okay. The inverse of plus 2 is minus 2, so we have x squared plus x plus box equals 30 plus box. Set up your perfect square. Your b divided by 2, 1 divided by 2 is going to remain a positive 1/2. Our b divided by 2 squared, 1/2 squared. Remember, when you multiply fractions, you multiply straight across, so it becomes 1/4. So when you add and subtract fractions, you have to have a common denominator. So 30 over 1. If we multiply both the numerator and the denominator by 4, we get 120 over 4. So when we combine those, 120 fourths plus one more fourth is 121 fourths. Okay, so to undo a to undo a square, we take the square root of both sides. So x plus 1/2 equals plus or minus the square root of 121 is 11. The square root of 4 is 2, so plus or minus 11 over 2. The inverse of adding 1/2 is subtracting 1/2. We write it as two separate problems, negative 1/2 plus 11/2. X equals negative 1/2 minus 11/2. So x equals negative 12 over 2, which simplifies to negative 6. X equals 10 over 2, which simplifies to 5. In example 3a, you notice that our coefficient is not 1, so we need to divide or factor out a 4. So when we rewrite that, we'll put our 4 on the outside. X squared plus 8x plus box equals our negative 68 plus our box, but because we factored a 4 out, there needs to be a 4 on the outside of the box on the right-hand side. When we write our binomial, it will still be x something squared. So when we do our b divided by 2, you want to look at your 8. 8 divided by 2 is equal to 4. 4 squared is 16. 16 times 4, so we'll put a 16 in here. 16 times 4 is 64. So negative 68 plus 64 gives us a negative 4. So we're going to divide by 4 to isolate our squared term first. So we have x plus 4 squared equals negative 1. Take the square root of negative 1. X plus 4 equals, so hopefully you remember that the square root of negative 1 is I, but we need to do plus or minus I. The inverse of adding 4 is subtracting 4, so we get x is equal to negative 4 plus or minus I. Remember to put your real part first, your imaginary part second. Example 3b. So this one we need to move our constant to the right-hand side by using your inverse. And we also need to divide by our 6 in order to make our a equal to 1. So we have 6 times x squared plus 2x plus box equals negative 42 plus, remember we factored out a 6, so we want to place that outside our box on the right-hand side. Our 6 will go outside of our binomial because this is the standard form how to set up an equation when we're solving using completing the square. Our b divided by 2 is going to go in our parentheses, so 2 divided by 2 is going to give us a positive 1. Our b divided by 2 squared is going to give us a 1 in both of our boxes. We need to combine our like terms. So negative 42 plus 6 is going to give us negative 36. So you need to isolate your squared terms. So the inverse of multiplying by 6 is dividing by 6. So we are left with negative 6 on the right-hand side. Square rooting both sides, so we have x plus 1 is equal to plus or minus square root of negative 6. Square root of negative 6 simplifies to plus or minus I root 6. The inverse of adding 1 is subtracting 1. So our solutions to this quadratic equation is x equals negative 1 plus or minus I root 6.